How's it going, everybody? Hope you're doing okay today. Hope you had something fun that you did recently and you partied and you threw stuff in the air. Anyways, in this video, we're going to be talking about matrices. Matrices are really cool. They really only were first started used to solve systems of equations, which is going to be really cool. It's awesome. I love matrices. But they were really first used in the 1800s. They were used by the Chinese, I think, in like 2 BC. Something like that, but it really popped up in mathematical texts in about the 1800s. So it's still kind of a recent concept. So you guys are learning stuff that like even 300 years ago they didn't know existed. Yeah. What a matrix is, it's essentially a system of numbers. Gauss created all this sort of stuff, but matrix is a system of numbers that has rows and columns. So like here, this matrix has 2 rows and 2 columns. In defining matrix and matrices, we say that this is a 2 by 2 matrix. We go rows by columns. It's just saying how big the matrix is, because depending on what we have, we can have different size matrices. So this one would be a 1, 2, 3 row, so 3 by 1 column, so that is a 3 by 1 matrix. And this one here has 1, 2, 3, 4 rows, 1, 2 columns. This would be considered a 4 by 2 matrix. And as I have down here, matrices will help us solve systems of equations. You're going to be so thankful that matrices exist and that you didn't live 200 years ago, especially since you have modern medicine. And in 100 years, they're going to be laughing at our medicine system because it's going to be even better. But anyways, that didn't matter. Medicine's awesome. Yeah, medicine. Do it. All right. So with these, looking at the systems of equations, you learned how to solve these by hand recently. We can also use matrices to help us solve systems of equations. We have kind of 3 matrices we need to set up. The first one is called the coefficient matrix. The coefficient matrix is just the coefficients, or numbers in front of variables, of our terms. So we have 2, 2, 4, 4, 1, 1, -6, -6. That is called our coefficient matrix. The next matrix we have is called our variable matrix, where I'm just saying that my first one was x, my second one was y. Because my first one was x, my second one was y. It's also super important to make sure that both of your x and y are first and second in your equations. All right, and then we have an equal sign, so we have equals. And then our last matrix that we use is called our constant matrix. So our constant matrix is just the numbers without variables. They are 15 and 10. I write them in order. All right, so now I have this set up. Matrix. We don't really divide with matrices. We can't really do that. So what we do is we do the inverse operations. Just like division is the inverse operation of multiplication. Well, the inverse operation of multiplying 2 matrices so that I can get xy by itself is I need to take the inverse of this matrix. So let's say I call this matrix A and I call this matrix B. In order to find the solution, I need to enter in my calculator, yes, you get to use your calculator, A inverse B. So here's how this is going to work. Ignore anything else I have on my paper, don't look at it. You are going to go to the matrix. Matrix is right above your -1 symbol. See it right there in blue? So if I choose second matrix, it takes me to this screen. We want to edit, we have a A and B matrix, so I will choose edit. I can edit my A one first, and it's asking for the matrix size. Well, we know our A matrix is a 2 by 2, so I'll enter 2 by 2. Even if you get it wrong, say you entered like a 3 by 2, you don't have 3 rows to enter. You only have 2 rows to enter, so you can go back and be like, oh, well that looks right now, because now I have all the numbers would have a spot. So I'm just going to enter the numbers exactly as they appear. So 2, 4, 1, -6. That is my matrix A. I will quit. I will go back to edit. Now I need to put in matrix B, which is a 2 row by 1 column, so 2 by 1. It is 15 and it is 10. All right, I will get back to my main screen again. So now I can actually do the math. All I want to enter is A inverse B. So I hit matrix A, I hit the inverse sign, which is that one that we clicked. Convenient that they put that by the matrix. Wonder why they did that. But A inverse matrix B, press enter. Ta-da! Those are our solutions. That's literally it. So like all this is telling us, we knew that x came first, so that is my x. X equals 8.125. Y came second, so that is my y. Y is negative 0.3125. So not pretty numbers, but hey, I'm really glad now that I had my calculator. So all I can do is write my ordered pair, 8.125, comma, negative 0.3125. That is our solution to that systems of equation. Cool, like super cool. All right, same sort of idea. So again, write the system of equation as a matrix equation. Oh, didn't even have to solve that. I'm sorry, I should have read the directions. Write the system of equations as a matrix. In doing this, that was writing it as a matrix. Bad. But that saves us some time later. So write the system as a matrix equation. So again, we have our coefficient matrix. We have A, we have B in order. We have the constants on the other side, so I can just go about writing my matrices. A comes first in both of them, and B comes second, equals our constant matrix. That's all we're looking for there. Yay! Oh, so pretty! Oh! Yes. All right, we have write the system of equations by the matrix equation, represented by the matrix equation. Read. So again, same sort of idea, except it's going backwards. Notice our x comes first, so this is my x and my x. Then I have my y, so y and y. Then I have my constant. So I have 2x plus 4y equals 8, and 8x plus 10y equals 10. Yay, that's the system. All right, here we have a 3 by 3 with a 3 by 1 and a 3 by 1. Again, still coming in order. So all that means is this is my x, this is my y, this is my z, equals 0. So I can have 8x plus 6y plus 4z equals 0. Oh, 5x plus 9y plus z equals 1. Hey, 2x minus 3y minus 6z equals 4. Oh, yeah! That's it. That's all you're going to be doing. We could even go about solving this one. We're not going to do it right now. We'll do one in just a little bit, but you can solve it. It's not too bad. So here's one. Zoom in, Earth cotton bugger. Yes. Solve the matrix using, solve the system using matrices. This is really early in the morning. It's 6:30 in the morning. It's too early. But that's how much I love you guys. Got my booze and bays. That's why, again, always make sure that your variables are in order. XY equals your numbers. If they're not, we're going to have to move some stuff around. We have negative 1, 3. So again, same sort of idea. Go to your calculator. Enter your matrix. Edit your matrix. Enter its negative 3, negative 1. 2 by 2. Negative 3, negative 1. 4, 1. Quit. Edit your other matrix. 2 by 1, it's negative 1, 3. 1, 3. We need to do matrix A, inverse matrix B. Hey, there's our solutions. So we have 2, negative 5. I will write it as the ordered pair because that's how we write systems, solutions to systems, and we will move on with life. All right, remember, you guys can pause, rewind, do whatever you need to do to make sure you understand what's going on. Come ask me questions. I love you. All right, looking again. So this one, notice, we do not have A and B on the same side. We need to move some stuff around here first so that we can solve this. So in getting A and B on the same side, I can subtract 3A. So I have negative 3A plus 2B equals negative 6. And I need to subtract 4A. So negative 4A plus 2B equals negative 12. So again, we can solve. We have our constant matrix of negative 3, 2, negative 4, 2. And our variable matrix equals our constant matrix. So again, coefficient matrix, variable matrix, constant matrix. All right, I'm just going to go and enter that in the calculator. -3, 2, -4, 2. So double checking. -3, 2, -4, 2. Beautiful. And then I'll go in and enter the other one. We have -6, -12. And we will do A inverse B. A inverse B. I'll press enter. Whoa! So my point is 6, 6. Cool. All right, same sort of idea, except now we have a 3 by 3. Again, make sure your variables, we have all of our x's, all of our y's, all of our z's lined up. They equal all of our constants. So we have 3, 2, -1, -2, 4, -3, 1, 1, -1. Our variables are x, y, and z. They are in that order in all of my equations. And I have 18, 4, and 12. All right, so we have our matrices set up. They match our equations. I can go into my calculator and edit my matrices. So now my first one here is a 3-row by 3-column. Again, you can always tell if you don't pick the right numbers, it won't match up with what you're seeing on your paper. So make sure you take the time to write it down. So 3, 2, -1, -2, 4, -3, 1, 1, -1. Yep. I was just checking my numbers, making sure everything looks right, because if you enter something just slightly wrong, it's going to throw off your whole answer. And this is so quick that you guys really need to make sure you take the time that you're typing everything in correctly. All right, so again, we will type in our calculator A inverse B. So that is just, oh, I killed my calculator. Hang on, I need to take it back to life. Give it some CPR, man. It's alive. All right, so we got some really ugly numbers. That's all actually to everything divided by 7. I don't expect you to know it's divided by 7, but it's really cool if it is divided by 7, because like it does the same sort of thing. 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 4, 2, 8, 5, 7, 1, 4. It's always 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. But you can write this as the ordered trio, 5.43, comma, -4.86, comma, -11.43. That's all I'm looking for. All right, so notice again, you had your variable matrix set up in x, y, z. So we know this is x, y, z in your calculator. Right? X, y, z. We write our ordered number in numerical order. Or sorry, alphabetical order. All right, moving on. Next thing. Multiplying matrices. We're just going to see what these multiply to be. And it's super easy because you get to use your calculator. You don't have to learn how to do this by hand. Something to note, though, is that if we are multiplying matrices, the inside numbers have to be the same. So say we have a 2 by 1 matrix times a 1 by 2 matrix. We have that. What I mean by the inside numbers. These numbers have to be the same. And what we get out after we multiply will actually be one 2 by 2 matrix. So say we had a matrix 2 by 4 times a 3 by 2. Makes no difference in the world that those outside numbers are the same. Those numbers are not the same on the inside, so this would actually not work at all. We would not be able to get a matrix out of it. So in multiplying these matrices, and your calculator will even tell you if it doesn't work, so it's not super important to know all of that, but it probably is pretty important because it can save you a lot of time. A, I'm going to go ahead and enter as the 2 by 2 matrix of 1, 0, 5, 6. B, I will enter as the 2 by 1 matrix of 1, 8. And C, I will enter as the 1 by 2 matrix of 8, 1. All right, so now it wants me to multiply AB. So hey, I can choose matrix A, and then I can choose matrix B, press enter. Oh, that's my result. That was so hard. Right, and then write the matrix 153. So that is what your calculator is telling you, the matrix 153. Don't worry about like the double brackets. If you kind of take one away, that's your matrix right there. It's just your calculator's way of saying that this is a matrix. All right, so again, AC, if we have matrix A, we have matrix C, dim mismatch. So all that means is that matrix A was a 2 by 2. Matrix C was a 1 by 2. Like I was telling you, these numbers are the same. This does not work. So this is not possible. We can't multiply those two things together. However, check this out. CA, you would think this is also not possible, right? But this should work because we have a 1 by 2 times a 2 by 2, and our result should be a 1 by 2 matrix. But let's check it out. You don't believe me. I know you don't believe me. That doesn't make sense. What are you talking about, crazy man? All right, C times A. Whoa! We have a 1 by 2 matrix. Imagine that. I got math right. Yay! So 13, 6. Wow, that is not 6. That is 16. Ignore that one right there. I don't know why I wrote it. All right, so you'd write the matrix there. Next thing, last thing, almost done, I promise. You guys are doing awesome. Inverse matrices. For an inverse matrix, say we're given a 2 by 2 matrix, it's really easy as long as it's a 2 by 2. The inverse, which is what we've been using this whole time to help us solve systems of equations, you switch the order of A and D, and you make B and C negative. So notice A inverse becomes DA, negative B, negative C. So in this first one down here, 2, 1 would become 1, 2. Negative becomes positive, positive becomes negative. That is your inverse matrix. Gets a little bit more tricky with a 3 by 3. So what we can use is our handy-dandy calculator. Oh, yes. And you can even use it by a 2 by 2, but that's how you do it by hand. 2 by 2 is way faster by hand. So edit our 3 by 3. I have 8, 1, 6, 3, 0, 4, 1, 2, 3. Boom. Yes. All right, and I just want the inverse of that matrix. I put it in A, so I will do A inverse, and it will tell me exactly what A inverse is. So see how ugly that is? We have 0.24, 0.15, negative 0.18. Also, you can scroll, so notice I'm hitting the right arrow, and it is moving my numbers to the right so I can see the rest of my matrix, because I know this is going to be a 3 by 3 still. So negative 0.27, negative 0.54, and 0.45. We got one more set over there. Negative 0.12, 0.42, there's a whole 0.09, and that is our matrix. All right, get lots of practice on this stuff. I will see you guys in class. Please, 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 please. You guys are going through this. Remember, you can rewind, you can pause, you can slow me down. You slow me down. Right off to the side what questions you have so I can help you the most. All right, I'll see you guys soon. Bye-bye.